Welcome to myprojectwizard.com. Let me discuss about the process, research and data fusion method for archaeological site identification. Let me discuss about the process, research and data fusion method for archaeological site identification. Initially, the multispectral images and the panchromatic images were collected. We know the multispectral images contains several bands and they have high spatial resolutions that contains more information about the color channels, and the panchromatic images have a high spectral resolutions and they does not have any high information about the color channels, but they contain the important spatial informations. So while combining these two, we will get a better fused images. So these fusion images will be helpful for further processing. So we are comparing several fusion methodologies. So in this we have taken IHS fusion, pan-shortening fusion, Brovie fusion, PCA fusion, Gram-Schmidt fusion and Atlas fusion. So by combining the multispectral image and the panchromatic images using these fusion methodologies, the fused images were obtained, and the fused images were compared with the input multispectral images and the panchromatic images based on the entropy value, standard deviation value and the mean value calculated. So thus we are providing a comparison method to compare different fusion methodologies in the fusion of multispectral and the panchromatic image fusions. Let me see the flow of the process. Research and data fusion method for archaeological site identification. Initially, the multispectral images and the panchromatic images were loaded. So, multispectral images contains several bands. The multispectral images has high spectral resolution, and the panchromatic image has high spatial resolution. When they are fused, the resulting image contains high spectral and the spatial resolution. Then we are applying several fusion methodologies in order to get the comparison of the different fusion methods. So first we are using IHS. So the IHS fusion, the intensity of the multispectral image is replaced by the panchromatic image. Spectral distortion may occur due to the fusion process. Saturation of the beam of the light is related to the width of the plot of the intensity. This is wavelength. The intensity is related to the strength. Then after that we are going to the pan-sharpening fusion. So in the pan-sharpening fusion, merging high resolution panchromatic image and the low resolution multispectral imagery creates a high resolution image. Pan-sharpening uses spatial information in the high resolution grayscale band and color information in the multispectral band to create a high resolution image, essentially increasing the resolution of the color information in the dataset to match that of the panchromatic band. Then after that we are moving to the Brovie fusion. So the Brovie transformation uses 3 multispectral and 1 panchromatic satellite image channel scene. So the Brovie transformation was developed to avoid the disadvantages of the multiplicative method. It is a simple method for combining data from different sensors. It is a combination of arithmetic operations and anomalous spectral bands before they are multiplied with the panchromatic image. It retains a corresponding spectral feature of each pixel and transforms all the luminance information into a panchromatic image of high resolution. Then after that we are moving to the PCA fusion. It creates uncorrelated feature space that can be used for further analysis instead of the original multispectral feature space. The PCA is applied to the multispectral bands. The panchromatic image is histogram matched to the first principal component. It is then replaced the selected component, and the inverse principal component transform takes the fused dataset back to the original multispectral feature space. The advantages of the PCA fusion is that the number of bands is not. Then after that we move on to the Gram-Schmidt fusion. The Gram-Schmidt fusion simulates a panchromatic band from the lower spatial resolution spectral bands. In general, this is achieved by averaging the multispectral bands. As a step, the Gram-Schmidt transformation is performed for the simulated panchromatic band and the multispectral bands with the simulated panchromatic band employed as a first band. Then the high spectral resolution panchromatic image replaces the first Gram-Schmidt band. Finally, an inverse Gram-Schmidt transform is applied to create the pan-shaped multispectral. Then we move on to the Atlas fusion. So Atlas fusion is based on IHS transform coupled with the 4-Radovan filtering. So combining, we are obtaining the fused images of the orders. Then we are comparing this using the calculated mean, standard deviation and entropy values. Let me see the execution of the process, research and data fusion method for archaeological site identification. So if you want to run the code, select the file main.m, which is located in the source code folder. Right click it and click on run file. You will get the guide video which is needed in order to run the code. So in the the guide window we will have all the user interfaces. So click on the load input button. So first give any one of the multispectral image which is present in the dataset. So image 1 image 2 are the multispectral images. So select any one of them and give the corresponding panchromatic image. So if we have given two images, then we are performing fusion using IHS. Then we are fusing this two images using pair shaping wavelet fusion. Then we are applying the Brovie wavelet fusion. So like that we are comparing the different fusion processes. Then we are using PCA feature extraction. Then we are using Gramsci feature fusion. Then we are using Atlas fusion, and finally we are comparing the performance of all the IHS fusion, pan-shaping fusion, Brovie fusion, PCA fusion, Gramsci fusion and Atlas fusion. So for performance analysis we are having three parameters: entropy, mean and standard deviation. So while calculating the entropy of the values, so these results were given, and while calculating the mean of the values, these values were identified, and while calculating the standard deviation of the values, these values were got. So thus we have compared different fusion algorithms to fuse multispectral and multispectral and the panchromatic images, so that we are going to select or combine several fusion methods to get a better result.